welcome to another episode of our Expert Interview Series for OnTechnicalDebt. Today I have the pleasure of being with Ward Cunningham, who is the founder of the term technical debt. So Ward is the current CDO of aboutus.org. He is the creator of the first wiki, Wikipedia's policies, CoffeeScript and Perl, and as I mentioned, he is the founder of the term technical debt. And I'm also here with Capers Jones. So Capers is the Vice President and CTO of NAM Cook Analytics. He's also part of the Consortium of IT Software Quality, and he's known for his association with the function point model and cost estimation. And he's actually been collecting a lot of data on software quality, software risks, and software best practices for several years. So this interview is going to focus on addressing the viewpoints expressed by the founder of the term technical debt, Ward Cunningham, and those of Capers Jones, which does take on a much wider economic approach to the topic. And to lead the interview, I'm here with Caroline Seaman. She is the Associate Professor at UMBC and the leader for Technical Debt Research Studies. She's also a research fellow at the Fraunhofer Center in Maryland. So Caroline, I'm going to hand it over to you so we can jump right into the conversation.
Okay, thanks Alexandra. And welcome Ward and welcome Capers. Thanks for joining us today. Ward, you first coined the term technical debt in 1992 as a software design metaphor. It highlights the compromises between the short-term gain of getting software out the door and getting the release done on time, and then versus the long-term viability of the software system. When you first used that term in 1992, was there a problem or an issue you were trying to solve or an issue you were trying to clarify with that term? What was your motivation for using that term?
I was very aware of that exact trade-off, and I felt that in commercial software development, that being able to find the right balance, and in particular having some choices when finding that balance was important, and so I was drawing the analogy between say venture-funded enterprise, where going into debt, building a company with other people's money was a good strategy. But I was also kind of pointing out the notion that part of that strategy is planning to pay back that debt, and so that. Of course, at the time I was thinking that refactoring was kind of a new concept. People would say, if it isn't broken, why fix it? And of course, there's very good reasons, even if something seems to be working right, that you might want to go back and improve it with the knowledge that you've gained through developing software. And so it was really an explanation for the economics of refactoring, the continuous learning process of developing software.
Okay. And of course that concept has sort of taken off, especially in the developer community and even in the software economics community, and to some extent more recently in the research community as well. And its definition and scope has evolved a bit. Capers, I wonder if you could say a little bit about how you see that term being used now in its more popular sense.
Well, it's used in a sense that was already articulated. If you skimp on quality before you deliver software, you end up paying heavy interest downstream after the software is released for things that you could have gotten rid of earlier had you been more careful. But I've been measuring quality since the 1960s at IBM, hundreds of companies, and I come at it from a slightly different fashion. And the fashion that I come at it is most companies don't have a clue on how to get rid of bugs before release. So they're not making conscious choices. They're acting out of ignorance because they don't know what they're doing. And if you look at the companies that do know what they're doing, you talk about the IBMs and the Raytheons and Motorola, they don't have much technical debt, and they don't have to pay very much upfront either, because they're using a synergistic combination of defect prevention, pre-test removal like static analysis and inspections, and very good testing. So they have minimum upfront costs and they have minimum technical debt because they know what they're doing. So my take is that a lot of the real technical debt, the high costs that come to us after delivery, is really due to ignorance rather than deliberate choice.
So Ward, talk a little bit about your current working definition of technical debt, if it's evolved since 1992, and what you think of what Capers just said about about technical debt now coming out of ignorance and neglect on the part of the developer community?
Well, of course, I think of software development as a learning process. And, even with highly skilled developers, if they're developing new software, there's an aspect of learning what's required to in a sense, satisfy the customer, and how to best express that with, contemporary technology. So that learning happens in the act of programming. My work in agile software development is to say, let's take part of what we understand and express that, and then react to that and express more, and react to that and express more. So it's an incremental approach. What I think is important is if you're going to take an incremental approach, you might learn something tomorrow that influences design decisions you've made today, and that should be considered a good thing. To be able to take tomorrow's learning and not discard it because you made a decision today. But that requires a set of practices that were unfamiliar early on. It was considered that especially in something like assembly language programming, where you had to make a bunch of decisions up front early, where how your registers were going to be used and so forth. That the power of modeling in a computer now, especially object-oriented programming, lets you delay those decisions. In fact, they're taken care of for you. So to take advantage of object-oriented programming and to have a lot of choices in a competitive environment, that you go out with maybe not a poorly written solution, but maybe an incomplete solution, or people will call it the minimum viable product. What's the least that you could produce to get you into a learning loop with your own customer? That's important.
Mm-hmm. So, Capers, I'll go back to you. Actually, I'll ask both of you this question, but I'll start with you, Capers. That some people view these two types of technical debt that are sort of opposite sides of the same coin. One is suboptimal design decisions that are made to help get the software out the door, and the other are actual flaws that are already in the software, defects that are in the software that are just not fixed and are left to be latent in the code. Are both of those things, in your view, correctly labeled technical debt, or are they different things?
I would call them both aspects of technical debt. And I add a third one, too, which is the security flaws in software that are invisible until someone exploits them, and then they can generate enormous costs for things like recovery from denial of service or recovery from data theft. So you have poor design decisions, you have quality bugs that cause the software to misbehave and produce incorrect results, and then you have security flaws that don't do much of anything until some clever person finds them and exploits them. And then you have a big bucket of expense.
Okay. So, Ward, what do you think about pushing a little bit on the definition of technical debt and what it includes and what it doesn't include? What do you think?
Well, as a metaphor, it was comparing technical issues, which in my mind, were the things that computer programmers were unnecessarily concerned with, relating their ability to wield the program that they had written so far, equating that ability to a financial situation. Certainly, when you borrow money, that enables you to buy things, and you can have things now that you haven't, in a sense, really paid for. So I see it very similar. You can have things early in a development and gain experience, and that is a good strategy so long as you really have a plan to pay it back. But if you don't pay it back, then you get this compounding where learning that you've consciously avoided comes back to hurt. You know, so you've got to learn a lot to get a good program written, and the question is, what order are you going to learn it?
Right. Okay, let me push a little bit on the metaphor again and see if we can stretch it into the finance domain a little bit more. Some people have said that technical debt is a little like venture financing. Does that make sense to you, Capers? I'll start with you. Does that push, that extension of the metaphor make sense, venture financing? How would that work?
Well, sort of, but in a sense, I hope it's not a good analogy, because in venture financing, barely 10% of the companies that get venture funding are successful. The other 90% fail. And venture companies are willing to put up with that because the returns on the ones that succeed are so high compared to the ones that fail. So that they tend to put money into questionable things. I would prefer to see a better plan for what the market really needs and a better way of building it, so you don't have so many failures, so that instead of a 10% success rate for venture funding, you have like a 80% success rate for venture funding, which we don't have yet. And I'd like to see the same for software. I'd like to see more careful planning up front so that we have much reduced costs. And if we do it right, we'll have reduced costs up front too.
Mm-hmm. Okay. Ward, do you have any thoughts on venture financing and if that extension of the metaphor works in any way?
Well, that was what I had in mind. That is, I was in a sense promoting a well-managed debt, and that one thing we like to say is if we're developing value every day, and that value is persistent, that the customer might decide that, gee, they have enough value now, even though they might have aspirations later, that they've created enough value now, and that they're ready to stop paying. Now, if we do that, then you want to know that value is real, and I think Capers has some very interesting statistics on kind of what was expected when a project was started versus what was actually delivered with the first release, and then ultimately what was included in a project by the time it reaches end of life. So those are three important points: when the project was conceived, when it was first delivered, and then in the lifetime of the project. And of course, Capers very good at counting out features in function points, and I think that's a just fine metric to normalize all the numbers he had. And maybe, Capers, could you mention kind of that breadth of project and kind of the long-term growth of projects over time?
Yes, I've been measuring the rate at which projects grow during development and after release. A typical project from the end of requirements until it's released will grow at an average of about 2% per calendar month, and about 10% per calendar month if it's an agile project. And then once it's released into the field, it will grow at about 8% per calendar year forever, for as long as anybody's using it. And I know that because that's the rate of growth of the IBM operating system. That was studied back in the 70s by Dr. Manny Lehman and some colleagues to look at how fast the IBM operating system is growing. And Microsoft Windows has been growing at about the same rate. They're looking at 2% per month during development and 8% per year forever, as long as anybody uses it, and that never seems to stop.
So I would say that the curse of success is that you have to keep working on the program, and often you have to keep working on the program, adding features that were unanticipated at the project inception, and that's what we'd consider success.
Okay.
Well, let me sharpen that a little bit. Let's say that when we're adding those features, that it's still a sound economic proposition, that the cost of adding the new features doesn't escalate because the program is somehow turned into an architectural mess, and that's what we're trying to avoid. I would say, when the time is right, can we take what we've learned so far and fold that back into the program to keep the program healthy and fit throughout its lifetime? And we want these programs to be successful, and we want them to grow. So that we don't have to throw them away prematurely and start over from scratch, and repeat all the same mistakes again, by the way, when we do throw them away and start over from scratch.
Okay, let me ask a question that sort of goes beyond the metaphor, or using the technical debt concept as more than a metaphor and a communication vehicle. What do you think of the idea of actually putting hard numbers on technical debt technical debt on the costs and benefits, and actually figuring that in a very quantitative way to planning and software development? Ward, I'll start with you. If we could do that, and a lot of people say we can't yet, but we might someday, if we could actually put good hard numbers that have meaning on technical debt, would that be a useful thing, or is that going beyond?
Well, that's taking the term beyond the metaphor and saying, let's take it out of the notion of software development and learning, and turn it into finance. So instead of being the CTO's responsibility, it becomes the CFO's responsibility. And I think that when you do that, you're throwing a much broader net, and the CFO should be concerned with that, because he's worried about the profitability of the company. But the CTO has some responsibilities there, but he also has to make sure that what he's going to be asked to deliver in the future, that he's capable of doing it. In other words, he also has some a banking of talent, and experience that needs to be in the bank, and it's a different kind of bank, right? It's can we attach a dollar value to the experience of the team? Well, probably if we step back far enough, statistically we can. But if we're talking about a particular team and a particular set of experiences and a particular style of learning, quantifying it in that becomes harder. It's like, if you're the CTO and you have to make decisions, well, you can step back and take a statistical point of view, or you could step forward and get close to your team and understand where they are.
Yeah, Capers, what do you think about that idea? Is there a usefulness to quantifying the concepts related to technical debt?
There's an older metric called cost of quality that has quantified data that's been around for quite a few years. And one of the things I've been measuring at IBM and AT&T and dozens of companies is what does it really cost to achieve various levels of quality. And let me just give you some industry numbers as a sample. The average cost of building a piece of software in the United States is about $1,000 a function point. And during development, about half of that, $500 per function point, is the cost of finding and fixing bugs. And then once the software is released, the first year it goes out, companies spend about $200 a function point in finding and fixing bugs after it's delivered. And then they spend about $250 per function point in adding features and enhancements. But after 5 years, if you've done it right, you're down to about $50 per function point in bug repairs, but what you spend on enhancement stays pretty constant. So if you've done it right, you have a first-year quantity of defect repair costs that declines quickly over time. On the other hand, if you botched it up, if you didn't develop the software well, if you were careless, you're going to spend $1,200 per function point to build it and $600 per function point fixing bugs. You're going to spend $300 per function point after release on fixing bugs, and instead of that number going down after 5 years, it's going to either stay constant or go up. So after 5 years, you can have a really bad project, but you're spending $350 per function point finding and fixing bugs, which at a time when you should have been down to $50 per function point. So actually, that kind of data, the cost of quality, is relatively widely known.
And Capers, I know that you also break down that information lots of different ways. And I know, or just a minute ago or something, you quoted some numbers and adjusted them for agile practices. And I wonder if from your perspective, if you see agile as delivering any value, or if there is some value, is it anywhere close to what proponents of agile have promised?
You get savings compared to waterfall of about 25% on schedules and about 30% on quality in the favor of agile. And that's most flavors of agile, including XP and agile with Scrum, and so forth. On the other hand, there are other methods that are just as good. Team software process by Watts-Humphrey and the rational software process generate results that are as good as agile. So agile is not the only successful method, but it's a lot better than waterfall.
And what we might be associated, I think there's something that we both share in common, and that is there's an inclination to assume the naive perspective that the first time something runs that it's done and you can move on, and several different approaches to getting to a completeness that you would be happy with. And that I would say that naivete or foolishness has led to a lot of costs, a lot of unnecessary risks, and what I'm a big fan of computers, of course, and so I say unrealized value. That computers can do things that people are not willing to attempt to do simply because they're afraid of them because they've seen so many disappointments. And so, of course, my interest is what can we do today that was hard to do yesterday, and that agile is certainly part of that. But it comes down to you're gonna have to pay sometime, and if you pay at the right time, you're better off, and that's really the CTO's job is to manage that timing and to spend people's attention well, and spend the company's dollars well.
Well, I agree with that. And if you are careful and prudent in the way you build the software up front, if you use static analysis and inspections, you'll find that you can lower your development costs, shorten your development schedules, and then have very little technical debt when it's released because you've done such a good job at the beginning.
Yeah, that's pay up front. It's don't take the risk of spending money you don't have, or shipping code you haven't thought through, or shipping half the function points when you have more to do that could impact your design. I would say because there's of course a lot of approaches to software that work. One that kind of surprises even me now is this notion that people who run big websites and are capturing logins as fast as they can are inclined to say, and maybe surprising even to me, is that they're less concerned with quality than they thought they needed to be, and they're more concerned with resilience. That is the ability to push forward even in the presence of a mistake, and that usually means when a mistake turns up, all the systems are in place to control the cost of that mistake, and and get backed up to a prior version. A lot of this is associated with A/B testing and the gradual rollout of new functionality. And of course, when we say quality, well, that is a different kind of, resilience is another kind of quality, and it's, there's just more choices on the CTO's table now than there might have been just a few years ago.
Right. I think part of what you're saying, Ward, is that, well, both of you, is there are costs of quality, and there are choices about how much quality you want to pay for and which qualities. And And that makes sense, and technical debt fits in well to that because you can trade off, current savings in the short term versus costs in the long term, and fold into that your expectations for quality. But one place where that you might run into trouble, I think, with that idea is when the quality gets to the point that a project is canceled and never delivered. So then the kind of making these subtle choices between the costs of different types of quality and different levels of quality kind of breaks down because then you've lost everything. Is there a way that the technical debt idea can help us think about that or help us manage the risk of that doomsday scenario?
Yeah, I know Capers has some numbers, so let's let Capers take that first and kind of paint the landscape for us.
Okay.
Well, as applications get big, the percentage of projects that are canceled and never released goes up. Above 10,000 function points, it's about 35% of projects that are started are never released. And the most common reason that they don't get released is because they had so many bugs they never worked. So there is a huge cost of quality connected with not doing things right and ending up with canceled projects.
I know as a developer, it's a real heartbreak to put your heart and soul into to something and to see a project struggle and watching it be canceled is a real personal blow too. I think it has a psychic damage on the industry. But I would like to kind of carry on this venture funding notion that the venture capitalists, if we want to look at how they manage their financial portfolios, they're less concerned about a company failure as they are about what they might call the living dead. That's a company that just won't die, but fails to succeed. Because in their logic, time is in the denominator, and so if you make a lot of money over 10 years, that's not as good as making a lot of money over 2 years, because it's time is in the denominator, and so fail fast is something that they appreciate. Big wins are appreciated much more, but if you can afford to take a portfolio strategy. And I would say that that all these little web startups that are doing this, that, and the other is really is a portfolio strategy. It's not something if you're equipping a submarine. Submarine software has to work, But if you're throwing up some new little trinket on the internet, then this venture strategy could be valuable, and I think that this sensitivity to size. If you have if you say you're a CTO at a big corporation and you're trying to figure out how to deploy some new internal systems, if you can figure out how to do it, in 10 small projects instead of one big project, and have some resilience in there, so if project number 4 fails, you can reconceive it 3 months later. That's a good approach. Of course, ultimately at the highest level, then there's an architecture that provides that resilience. How are you going to organize? How are you going to organize those 10 parts to be a whole? And lots of choices in front of us now in that way, and that's what I would encourage everybody to explore, is to know how many different ways you can deal with that, and then match the approach to the needs of your software and the capability of your people.
Okay, well, related to that, as far as sort of choosing your level of or your approach to dealing with technical debt. Capers, actually, I have a question for you. A lot of your work, it's in numbers, and you're the measurement guy. What if an organization has a very mature understanding of technical debt, but a very immature measurement culture? So a lot of companies have, are just very low maturity in terms of measuring things and collecting data and building models and having historical baselines. But it doesn't take all that to understand technical debt and how it manifests itself. So are there ways that an organization like that can track or manage or do something about technical debt without a big measurement infrastructure?
Well, there are some measures that don't take much effort that are useful and would play into the concepts of technical debt. There's a comparatively straightforward metric called defect removal efficiency. You keep track of the bugs you find during development, and then 90 days after the product is released, you keep track of the bugs the customers reported, and you calculate the percentage that was found internally. As an example, if you found 90 bugs inside, and the customers reported 10 bugs, you were 90% efficient in removing defects. That's not a particularly burdensome measurement, but it generates enormous value, and it plays nicely with technical debt, because the leading projects, the ones where people really know what they're doing, are going to achieve something like 99% defect removal efficiency, so only 1% of the bugs get released into the field. The U.S. average is only 85% defect removal efficiency, and for a software organization to release 15% of all defects to an excited public, to my mind, is hovering near malpractice, and this is something that should happen. The thing about it, if you don't know how many bugs you find inside, the only thing you know is how many bugs that come in after release. You have no ability up front to make it better. So if you don't measure anything, you have very little ability to get better over time.
Mm-hmm. Right. Okay. Ward, do you have any thoughts on well, we talked about this a little bit before about how the technical debt metaphor and concept doesn't need or you expressed that it doesn't really need quantification to be a useful thing. But if people really want to manage it, how would they go about that on a day-to-day management basis without some good measures?
Again, let me think. If you step 2 steps back, then you want to look at risks. What are risks you're assuming, and so forth. As a business, you have to know where your money's coming from and where you're spending it, and scenario analysis sort of thing. What could go wrong, and what could go wrong probably will go wrong. So you've got to just remove the possibility of things going wrong, and that seems to me to be a good business. When it comes to talking about a development organization, what we like to do is, when I step 2 steps closer, and the way I like to do that is actually sitting down with people and programming at the limits of our ability together, this pair programming, and you kind of see into each other's head, and you can kind of see learning strategies and test strategies and so forth. What I would do is I would ask myself the question, in that hour of programming together, how many minutes were we grappling with problems that we could explain to the customer, and our customer would say, "I'm glad you were grappling with those. I'm happy to be paying you to think through that kind of decision." And how many minutes of that hour are spent just dealing with foolish things, crazy things that just happen using the computer, that if you had thought twice you could have prevented, but you didn't think twice, so you just have this nuisance level. And they're complicated. You could never explain to your customer. It isn't about the customer's business. It's about your business, and you're letting your business get in the way of doing the customer's work. And that kind of, that's an intuitive ratio. But I think that, computers and computer programming is filled with those little nuisance things. But if you can beat that back to the point where you do a significant amount of grappling with a customer's problem every hour, then you're in good shape. I don't think we can ever take the tedium out of computer programming, but if you can do something for the customer every hour, then then you're moving forward.
Okay. Yeah, I like that. I don't know if you would call it a measure, that ratio of how much time you spend in the solution space and how much time you spend in the problem space, I guess, is another way to say what you said.
Well, I've heard stories of new managers walking down the hall and stopping people and say, "What do you do here?" And then listening to the answer and deciding if that has any true value creation or if they're just doing busy work because of the bureaucracy of their organization. Well, we could talk about the bureaucracy of the computer programs that people make one way or the other, and if the computer program is turned into its own little bureaucracy where you can't actually on a daily basis create value, then you know that the technical debt, the debt that I was talking about in my original metaphor, is piled up, and you're paying that interest.
My next question is again back to expanding the metaphor and into the finance domain, and trying. A number of us have had long conversations about which financial concepts can fit into this sort of technical debt framework, and I'd like to ask both of you what you think of things like litigation expenses, liabilities, opportunity cost, any other sort of financial concepts or mechanisms, tools really, from the finance domain that we could adapt in the software domain under the framework of talking about technical debt. Either of you can, if you have a thought, jump in.
Well, I think the generally accepted accounting practices, that all accountants follow, might be analyzed, and then a similar series can be set up for technical debt.
I think we lost a little bit of your sentence there.
Yeah,
I think that generally accepted accounting practices, the standard practices for financial accounting used by all American companies, could be merged and modified and used as the basis for technical debt accounting standards. I think if you don't have accounting standards for technical debt, every company will do it differently, and then you can't compare one company's technical debt to another.
Okay.
So what I hear Capers saying is that what I might have called technical debt is kind of at a personal level, and commitment on the individual to do a good job, but that as you move up in the organization, there becomes a responsibility. And I think the CTO, I compared the CFO to the CTO. We know that the CTO as a company officer has financial responsibilities. Everybody at that level has financial responsibilities, and they should be held accountable to shareholders and so forth to be considering that. And whether that's called technical debt or risk analysis or something like that, I think technical debt is probably a new name for an old thing there. But certainly at the CTO level, that matters.
A little while ago, Capers, you brought up the issue of security flaws and security issues in software and what costs those can incur. And I wonder if you could talk just a little bit more about how the technical debt metaphor can be used to think about security flaws and security flaws that either cause data theft or denial of service attacks or some other bad thing down the road. Can we use the technical debt idea to think about how to manage those risks?
Well, you can, but security flaws are a special breed. You need to be a security expert as well as thinking about the long-range costs of fixing things once the software is released. There's one alarming new security problem that's just surfaced. Let me give you an example and see how that might work on that one. You know those plastic cards that hotels use to open the doors, all the door locks? It turns out that there's a hacking device available And people have been stealing computers and jewelry and everything else out of hotel rooms because people can hack into those badge lock doors. And so hotels are being sued for not having adequate locks. So the question is, the company that put that software in the door locks, are they liable for the theft? How would Technical Debt handle something like that particular security flaw that the door locks on hotel rooms aren't secure anymore?
I would, of course, that's a scary thought, and we know that most criminals are pretty dumb, but there's a few that are pretty smart, and unfortunately, we do see a situation where crime pays.
I'd like to raise another issue too, if I might. A lot of the problems that end up being technical debt after they're released really originate with the clients. They don't originate with the programmers. I worked as an expert witness in a lawsuit where a company was suing a software vendor for a Y2K problem, the two-digit Y2K thing. And it turned out, in the depositions of discovery of this case, the vendor warned the client not to use 2 digits. The vendor told the client that they were going to get trouble and they should use 4 digits. The client refused to accept the vendor's advice and insisted on 2 digits. And so when this came up in the lawsuit, obviously the plaintiff brought the suit because it was their fault. The programmers didn't want to do it, told them not to do it, and they were overruled. So when the clients themselves are the source of the problem, that's another aspect of technical debt. This is just the developers, and sometimes the clients themselves insisting on doing dumb things.
All right. Well, I've come to the end of my questions. Are there any final thoughts that either of you would like to add before we sign off?
Well, it's a great metaphor. I think the concept of technical debt has reverberated through the industry, and it's making people think about design issues and quality in a fashion they never did before. So I see it as a significant value-added concept for the industry.
I feel the same way, and I'm proud that something that kind of started as an offhanded conversation with my own CEOs has legs beyond what I had even intended. My only hope is that in this process that we don't take it so high that it stops being useful at the level where I wanted it to be useful, and that was basically encouraging developers to not only be fortune tellers and to anticipate the future, but when the future turns out to be different than they anticipated, to just take the extra effort to keep their work current with their understanding. It's a learning process for them, and the software should learn too. And if there's a little cost to doing that housekeeping, let's call it housekeeping, then learn how to keep that cost down so that we can produce more quality software and get more return on our investments, and let computers grow to be everything that they can be.
Okay, great. Well, thank you both so much. I really appreciate it.